Hi, this is Math 8, Unit 5, Lesson 19, Estimating a Hemisphere. Alright, so we talked today about what a hemisphere is, and a hemisphere is like half of a sphere, right? So it has kind of a rounded bottom, just like so, and it's half of a sphere. That's hemisphere. So it says here the hemisphere-shaped security mirror fits exactly inside a rectangular prism box with a square base that has an edge length of 10 inches. What is a reasonable estimate for the volume of this mirror? And we looked at some of this today in class. We talked about basically that if you took a cube like so, and it had a base and a height of 10, the volume of that cube would be 1,000, well, if it's inches cubed. If you took a cone we've said before could actually fit inside of a hemisphere. So if your hemisphere is like so, a cone fits inside of that. And so a volume of a cone is about 1/3 of the pi r squared times h. So if you think about a cone being inside of here, of the circle, like so, you'd say, well, that radius is about 5 because it's halfway across. So we're talking 25 times a 5, which is 125, and 1/3 of 125 times pi get you somewhere like 130.8, right? So there's a big difference between 130.8 and 1,000, but a hemisphere is going to be somewhere in between those two. So again, you're looking for a reasonable estimate of what that could be. We talked in a little bit, at least in my video thing, about a hemisphere being about 2/3 of something. So doing the same measurement, but 2/3 instead of 1/3. That would be a good reasonable estimate as well. So give it a shot, see what you come up with, and then compare it with maybe some friends and see what you got in class tomorrow. Number 2, the volume of the cone is approximately 16.5 inches cubed. Determine the height to the nearest tenth. Alright, so we have the volume equals 1/3 pi r squared h, and we're given the volume 16.5. We keep the 1/3. For pi, we're going to put 3.14 since we're approximating the nearest tenth. We're assuming we're not keeping in terms of pi. This was 3, so the radius would be half of that, so it's 1.5 squared, and then we'd find the height. Okay? So what we have to do now is what we've done many times before. We're going to go through and divide this out and then move it over there to see what the height is going to be, and you can solve that one on your own. In doing so, you're going to find a pretty close number. Because the nearest tenth, you need to do a little bit of rounding to figure out what that's going to be, but that's a good setup to get you started there. Alright, number 3. The volume is that. Determine the diameter of the cylinder, the nearest tenth. Okay, so let's do one of these. We have 1847.3 equals 1/3 times pi, 3.14 times the radius squared times a height of 12. Alright, so I can go ahead and first of all multiply 3.14 times 12, which gets me, well, what's that going to get me? Well, 3.14, my notes aren't quite clear there. So 3.14 times 12 equals 37.68. Keep the radius squared, and I still have a 1/3 equals all of that. So now we can take 1847.3 and let's multiply it by 3. Multiply both sides by 3 to get rid of that. Let's multiply it by 3. We have 5,541.9 equals 37.68 radius squared. We'll divide it by 37.68. 37.68, and we have 147.07 equals radius squared. So we're going to take the square root of that and find out that it's about 12. About 12 is what the radius is going to be, something like that, something close to that there. So if that's the radius, we want the diameter, we'll multiply 12 by 2 to get the diameter, and we'd say diameter is about 24. Now, I'm not sure if that's totally accurate or not, but it's kind of a good approximation there to the nearest tenth, just kind of giving it a guess. All right. So does it work out? You can work the other way and see if it works out. I mean, if the radius is 12, we would do pi times 1/3. Oh, sorry, 1/3. Oh, that's what it is. Huh, I knew I was doing something funny. So sorry. Let me back up a little bit. Back it up, back it up, back it up. You know what I was doing? What did I do? I added this. Ignore that. We're not doing a cone, are we? Ignore that, and let's back it up all the way to here. Oh my goodness. I thought I had caught a mistake while I was doing it, but I went too fast. Alright, so we have 1847.3, and we divide it by 37.68. I included that 1/3 all the way through, so sorry about that. So this divided by that actually equals 49.02 for the radius squared. So if we took the square root of both sides, 49, square root of 49-ish, again we're doing nearest tenth, let's just kind of ignore this, should be about 7 for the radius, which then we do 7 times 2 for the diameter, it would be 14 for the diameter. That makes more sense. And we're good to go. So sorry. Number 5. I'm going to do 5 here since they're very similar. We have 7. Great. We have 6. And then we do negative a half times 4, or 4 divided by 2 is negative 2m. And then 6 divided by negative 2 is a negative 3. So let's combine those two together. So 7 equals 6 minus 3 is 3. Let's subtract 3 from both sides. So we have 4 equals negative 2m. We divide both sides by negative 2, so that negative 2 equals m for our solution. Alright, there you go. Go ahead and solve 4 and 5 as well, and you'll be good to go for the day. Have a great one. We'll see you next time.